evaluating special trig limits. And in our class, the last period, we discussed what those special trig limits were. So let's just take a moment to write them down, and we have them at our fingertips. The first one said that the limit as x approaches 0 of sine x over x equaled 1. Now there was a second one, and that one said the limit as x approaches 0 of the expression 1 minus cosine x over x equaled 0. And we proved both of these in our last class period by looking at a graphical analysis and a numerical analysis. So assuming that both of those are true, let's continue to solve these problems. Our goal will be first to attempt direct substitution, and if that doesn't work, try to make the problem look like one of these special trig limits. So what I'm going to do for the first problem is notice that what I have here looks very similar to one of the trig limits, but there's this 5 in the denominator. So what I'm going to do is I'm going to write this in the following way. The limit as x approaches 0 of 1 over 5 times sine x over x. So sine x is on top, it's still on top. 5x is on the bottom, 5x is still on the bottom. Now we can apply the special trig limit. 1/5 remains unchanged, and the limit of sine x over x as x approaches 0 is 1 according to the special trig limit. So the answer overall is 1/5. Okay, for the second one, it's the very same idea. What I'm going to do is I'm going to take that 3 and move it out in front. So this is the limit as x approaches 0 of the expression 3 over 1 times 1 minus cosine x over x. Now this is one of our special trig limits. When x approaches 0, for that expression it equals 0. So what we're left with is 3 times 0, or 0. Okay, moving to the next one. This is a little bit more complicated, but maybe you're starting to get the hang of it a little bit. The fact that we have sine x on the top and an x squared on the bottom is kind of a good thing, and then we have 1 minus cosine x over another x, and it's really just a matter of what we're going to do with that 2. So what I'm going to do is set my limit up, and some students get a little bit lazy with this, and you really shouldn't. You have to be very careful with your notation. So what I'm going to do is say the limit as x approaches 0 of 1/2 times sine x over x, so I've taken care of one of these x's, times 1 minus cosine x over x. So again, the bottom is 2 times x, or 2x squared, and the top is sine x times 1 minus cosine x. I've essentially taken the fraction and pulled it apart. So the 1/2 stays, sine x over x is 1, 1 minus cosine x over x, that special trig limit is 0. So if we find the product of all of these, the answer is 0. Okay, moving on. This one. Okay, so what I'm going to do first for this one is I'm going to write tangent as cosine over sine and see what happens. Again, not to be lazy in not writing this limit portion of the problem over and over again. I'm going to do it. We have cosine of theta times sine of theta over cosine of theta all over theta. And what I see happens here is that the cosine thetas cancel out, and I'm left with the limit of sine theta over theta as theta approaches 0? It's one of our special trig identities. And the answer is 1. Okay, moving along. Now, just looking very quickly, if I were to do direct substitution and substitute in 0 for x, I would get indeterminate form. So I'm going to think of another way that I could possibly handle this. And I'm thinking maybe using the Pythagorean relationship for the numerator. So I'm going to write the limit as x approaches 0 of 1 minus cosine squared x over x. Now I think this is still going to give me indeterminate form if I were to substitute in 0 right now. So I'm going to do difference of two squares on the top. Again, I'm not going to be lazy with this. It's so hard to not be lazy. So if I do the difference of two squares, I'm going to get 1 minus cosine x and 1 plus cosine x. Extend that fraction bar, and this is over x. Now this is one of our special trig limits. So let's take a little shortcut. I'll use a different color here so you can definitely be sure of what I'm looking at here. But this right here, as x approaches 0, is the value 0. So that means our first evaluation of that limit is 0. Now when I do direct substitution into the remaining expression, we know that the cosine of 0 is 1, and 1 plus 1 is 2. Not that that matters a whole lot, because 0 times anything is 0. Okay.